In this video, we will look at how to compute probabilities associated with the normal distribution. And we will primarily focus on using Microsoft Excel as a computational tool. You'll recall that for a normal distribution, about 2/3 of the data are within one standard deviation in the middle. Go out 2 standard deviations in the middle, you've got about 95% of the data. Go out 3 standard deviations in the middle, you've got virtually all the data. And so, for example, SATs, normal, mean of 500, standard deviation of 100, about 2/3 of the population will have an SAT math score between 400 and 600. The remaining 1/3 of the population, about half of them will fall below that, and about half of them, or 1/6 of them, will fall above that. So, question. Suppose somebody scores a 650. What percentage of the population scores 650 or below? If you score a 650, how many standard deviations away from the mean are you? A 600 would be 1 standard deviation above average. A 700 would be 2 standard deviations above average. But you are how many standard deviations away from the mean? You're 1.5 standard deviations away. 150 points, 100 points is 1 standard deviation. You're 1.5 standard deviations above average. This is a pretty intuitive computation. We're simply counting how many standard deviations away from average we are. It's fairly simple, and it is the most important computation in all of inferential statistics. We're simply computing, start from our observation, subtract off what we expected, divide by the number of standard deviations. It's something statisticians call a z-score. We're simply asking how many standard deviations away from the middle are we? And so asking what percentage of the population has scores below 650 is equivalent to asking what percentage of the population scores 1.5 standard deviations above average or less than that. Let's draw a picture. You should always, always, always draw a picture. On our bell curve, standard SATs run along the horizontal axis here. Average SAT is 500. We want the area 650 or less. We want this area shaded in red. Notice it's 1.5 standard deviations away from the middle. How do we find this area? Because we've got magic benchmarks for 1, 2, and 3 standard deviations, but we don't have one for 1.5. So what do we do? There are 3 different approaches we could take to find that probability. One is to realize, okay, we're looking for area under a curve. Oh, that's a problem from the calculus. Oh boy, won't that be fun? All we do is take the function that's the height of that curve and integrate it out over the bounds of interest. No problem. I do not recommend this approach. Second thing we could do is use a printed table. Some of you may have had an introductory statistics class in high school and you saw something that looked like this. You looked things up in a table. Now that's a pretty easy way of finding normal probabilities, but it's also a pretty 19th century way of doing this. This is a legacy of the bad old days before everybody had very accessible computational technology. If you know how to use one, go with it, run with it. I'm fine with it. However, it is a bit dated. What we will focus on in this class is software, and in particular a Microsoft Excel function. Within Excel, there are a couple of basic functions you can use to get normal probabilities. If we're dealing with data still in its original units, we can use this norm.dist function. If we've computed a z-score, a number of standard deviations away, it's norm.s.dist. The S stands for standardized. And so in our problem, we wanted the chance of scoring 650 or less on the SAT. So we're scoring a 650 or less. The mean is 500. The standard deviation is 100. And we tell it true. Yes, we want the whole area under that. Basically, this is a programming issue with Microsoft Excel. Just always tell it true. Alternately, we could say, hey, a 650 is 1.5 standard deviations above average. And so our z-score was 1.5. Norm.s.dist of 1.5. And again, true. You don't have to remember the exact syntax. Remember, you can always use the function wizard in Excel. And so click on the cell where you want to put your answer. Hit this FX button up here to bring up the function wizard, and you will get a dialog box that will walk you through in constructing the function that you want. Select statistical functions. It will bring up a list. You could do norm.dist or norm.s.dist. Select OK. That asks you to type in what you want the computations based on. I selected norm.s.dist. I wanted 1.5 standard deviations above the middle, and true, and it spits out my answer, an answer of 0.9332. In other words, 93.32% of the population has an SAT math score of 650 or less. For this class, you should be able to find probabilities associated with the normal distribution. I encourage you to use Microsoft Excel built-in functions to do so. However, if you already know how to use printed tables and you're already familiar with them, that's a perfectly valid approach as well. The next video will walk through several more examples to help us make sure that we're truly able to do these computations.